Okay, so moving on to the next topic of forces with your centripetal force. So what is centripetal force? So this one is good for you to learn about your centripetal force. Centripetal force helps object to move in circles. So for circular motion, the object moves in a circular path, right? Okay, so why do they not get swing out? Because there's a centripetal force holding them back in. So this is the centripetal force. This force here is your centripetal force. So if not, you see the girl is swinging on this merry-go-round. If there isn't a centripetal force holding her inwards, then she'll be swing out of this merry-go-round, correct? So what's holding her back in and allowing her to spin in circles is your centripetal force. Okay, so some examples will be an orbit. So an orbit is a circular or oval path around the central point. So for example, for Earth, our satellites will orbit in a circular motion around Earth. So we have the center of Earth, the center of Earth over here, and this satellite, for example, it moves in a circular path, okay, or oval path around the center point of Earth. This is called an orbit, okay. It's a circular or oval path. Okay, the circular or oval path where the object moves in a circular motion around the center point is called your orbit. So some examples of your solar system. So for solar system, you see all the different planets will orbit around the center. So this center is the sun. Okay, so there's a centripetal force that's holding all these planets towards the center. Okay, this is your centripetal force, such that they'll remain in your solar system and not move out of this solar system. Okay, so this centripetal force allows them to move in a circular motion around the sun. So same for satellite, as I just explained. So they all orbit around the center point of Earth in a circular or oval path, okay, which is your orbit. So the direction of object in a circular path is constantly changing. You see, at this point, this ball is moving this direction. At the next point, it's moving towards the right. So upwards, then to the right, then downwards, then to the left. Okay, so this direction is constantly changing. So an object that moves in a circle or your circuit, which has your circular motion. So this is what we call the objects moving in this path. They are moving in a circular motion. So this direction is continuously changing its direction. Okay, so the speed is the same, but the direction keeps changing. Okay, so there's a force that comes from the center and pulls the object inwards. If not, this object will just continue to move in this direction and leave the path. Same for at this point in time. So when there's this centripetal force that's holding them back in, they are able to move in your circular motion. Okay, so there's a force that comes from the center and pulls them into the orbits, and this force is called your centripetal force. Okay, allows object to move in a circular motion. So without this, or this object will just continue in this direction and leaves the path. So some of the factors affecting your centripetal force. So first thing, the heavier the mass of the object, the higher the centripetal force. So with this object over here, this person is swinging it in rounds, right? So he's spinning his body and spinning and swinging this object over here around. Okay, so if this is very heavy, then the centripetal force will be greater, because they will need a greater centripetal force to hold this heavier object in. So therefore, when it's heavier, there will be a higher centripetal force, because you need a greater centripetal force to hold this object back in. If not, you will leave the orbit, correct? So if you compare this 60 kg one and the 20 kg one, this is your greater force, and this one will be weaker or smaller in magnitude. Okay, so next, the faster the object is, the greater the centripetal force is. Okay, so you see they are moving in this direction at the speed of v, your velocity, right? So if this is faster, then you need more force to hold them back in. Okay, so if this bicycle is slower, then this one is lesser compared to a car, because a car is moving faster than bicycle, so we need more centripetal force to hold this car back in within this circular path. Okay, so when this car is driving in a roundabout, it has a greater centripetal force as compared to your bicycle. So next, the greater the radius of the circle, the smaller the force. So you see, if you look at this person over here, it is very far, right? It's further away from the center. So it is A, and A as a, for A will have a greater radius. Okay, as compared to B, which is this person here, B. So B has a smaller radius. So if the radius is greater, then the centripetal force is smaller. Okay, so this person over here, the A, has a greater radius, and therefore A will have a smaller force as compared to B, which is a smaller radius and therefore greater centripetal force. So this is the third factor that affects your centripetal force. So some interesting fact for you: if the object is at the end of the rope, the centripetal force is tension. Okay, so you see what's holding this ball is your centripetal force, right? But if you look carefully, this is actually your tension from the rope. Okay, tension from the rope. This is acting as the centripetal force. So this is the one that is holding back in, which is the rope. Okay, so without this rope, if you imagine this rope suddenly disappear, then this ball will just continue flying out and flies away from this central point, which is the buoy. Okay, so it leaves the circular motion or the orbit. Okay, then if you imagine a car driving round and round, so if this is center point, there's a car driving around it. It's a car, right? It's a car. Okay, it is driving round and round and round. So without this central force, which is your centripetal force, it will fly out. And what's holding them back in is friction. So for a car driving in circles, the centripetal force is your frictional force. Okay, so centripetal force can be in many different forms. Okay, then for satellites orbiting about Earth, this is your Earth, then your satellite, right? Orbiting about your Earth, this is your satellite. What's holding them back in is your gravitational force. So therefore, your centripetal force is a force that holds the object in it in a circular path, which is your orbit. And it comes in different forms. For satellite, it will be your gravitational force. For this boy swinging the ball, it will be your tension. And for a car driving in circles, it will be your frictional force. Okay. So for satellite, the centripetal force is your gravity, which is your gravitational force. So there's gravity acting on this satellite, holding back into the center. Remember? So for an object that has a mass, there will be a gravitational force that acts on it, which gives it a weight. So it brings the object towards the center of the Earth, right? So this allows the satellite to move in a circular motion. Okay, so this requires some of your knowledge from the gravitational topic. So why is centripetal force useful? An object that cannot travel in a circular motion unless there's a centripetal force that directs it, okay, towards the center. So we need a centripetal force to direct it towards the center for a circular motion to take place. So the moving object is pushed towards the center of the circular path by centripetal force. So without centripetal force, you see, these other planets can no longer orbit around Earth. So this is your moon, right? It can no longer orbit around your Earth because there's no more centripetal force. Okay, so therefore centripetal force is very useful because we need circular motion in our lives, and your centripetal force will allow your circular motion to take place. Okay, so this is why our centripetal force is so useful. Okay, with that, we've come to the end of your centripetal force.